So you guys, we are on section 10, 2A, and we are graphing quadratic functions. Now, technically we graphed yesterday as well, but today we're going to throw in that third letter. Yes.
Is there the video?
Yes. Okay, so we have a quick review of what we learned yesterday, or tried to learn yesterday. Y equals ax squared plus bx plus c is our general standard form of a quadratic equation. And we learned that A tells us a couple of different things. What does the A tell us?
Height. No. Sorry. Force.
Okay,
Force.
rainbow
Oh, force.
or smiley? What else does the A tell us from the graph?
Narrow
Rotation.
or wide.
Narrow or wide. So those are the two things that the A tells us. Rainbow or smiley, narrow or wide. What is the role of the C?
Gravity.
Okay, so it is, we call it the vertical translation. Does that make sense? Vertical. What we're actually going to see is that the role of C is actually the y-intercept. The y-intercept. So sometimes it's the vertex, and sometimes it's not the vertex, but it will always be the y-intercept. So it's always where our graph crosses the y-axis. Yes.
C being added to that? No.
B is what we're adding to it today.
Okay. What?
Okay, so we're going to do a quick sketch review of y equals negative 3x squared. Where's the vertex? 0, 0. Is it rainbow or smiley?
Rainbow.
Is it wide or narrow? So it's a narrow rainbow, so it's going to go down and be kind of close to our y-axis, right? Snuggled up next to it. Okay, now that is a nice quick sketch when all we have is the A of the ABCs. Now we have y equals 1/2 x squared minus 3. So now we have an A and we have a C. What does the A tell us in this problem? Right here, 1/2.
That's wide, and it's smiley.
It's a wide smiley. What does the negative 3 tell us? Somebody else.
Go down.
We're going to start at negative 3. That's our vertex is going to be at 0, negative 3. And we're going to have a wide smiley. Okay. Oh, I should have done that on the other one. Yeah, whatever. I had 2 graphs for it, but I'll use that graph for here. Huh? Okay. So now life gets a little more complicated. We get to deal with B. Now that's okay. It's all good. No worries. That's why you have me. So I can teach you how to do this stuff. Okay. Now, what the B does is it takes those graphs and it moves it from the center. Now, before our y-axis happened to be our axis of symmetry. Remember, it's the very middle of the graph. It shows the mirror image on both sides, right? That was always on the y-axis. Well, now we're changing it. We're moving it. It's called horizontal translation. So what does the B do? Moves it from side to side. So okay. Now the A is still going to tell us the general idea of what this graph is going to look like. Is it going to be a rainbow or smiley? Is it going to be narrow or wide? But the B causes it to shift. So that means we are going to use this very, 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 very important formula to find the vertex shifted off its center. Hey, Jacob, something more things? Okay, well, you still drew something, right? Okay. So in order to find the x of the vertex, we need to do negative b over 2a. So that would be step one. So step one is to find the axis of symmetry, which is also the x of the vertex. So here is my example. See that right there? Y equals negative 3x squared plus 6x plus 5. Now the first thing I'm going to do is I'm going to identify my ABCs. Now, hey, look, we're going back in time to our ABCs. Oh, life is easy then, right? What is the A? What is the A in this equation right here?
Negative 2x.
We just take the coefficient, so it's just negative 3. What is the B? And what is the C? Does everybody see where the ABCs came from? The A is the coefficient of the x squared, the B is the coefficient of the x, and the C is the constant. So step one is we're going to find the axis of symmetry using this formula right here. We have our ABC, so x is equal to negative b over 2 times a. All right, so let's simplify this. That's negative 6 divided by negative 6, which happens to be 1. So x equals 1 is my axis of symmetry. That means that's the very center of my graph. So let's move over here and let's put that in. X equals 1 is my axis of symmetry. It's also going to be the x of my vertex. So my vertex has an x value of 1. But I don't know the y value yet. So this is step 2. So for step 2, we take x equals 1 and we plug it in into the equation. Remember, my equation is y equals negative 3x squared, only this time we're going to put 1 in for x. So I'm going to do negative 3 times 1 squared plus 6 times 1, because we're replacing every x with 1. And now I could just do the PEMDAS steps and solve this out for y. So 1 squared times negative 3. So negative 3. 6 times 1 plus 5. So I have negative 3 plus 6 plus 5. What does that give me? 8. So y equals 8. I just found my vertex, you guys. Woohoo! That was the hard part. That wasn't bad, was it? So 1, 8 is my vertex. All right, now let's go back to that A. Remember that A was negative 3? Right here. What does that tell me about the graph? It's going to be a rainbow, and it's going to be pretty narrow. We want to know how narrow. So you remember C hasn't done anything yet. It's kind of just sitting there, biding its time. What did I say this was? But it's also a y-intercept. So this is where it crosses the y-axis. So on the y-axis, I have a point right here. So from my vertex, I'm going to do this. Remember that axis of symmetry? What does that axis of symmetry do? it's the exact same on the other side. So if I have this from my vertex, and I have this on the other side, and that's my graph. Does that make sense?
Yeah.
So there's like 3 steps here. You have to use that negative b over 2a to find that x, the x-axis, or the axis of symmetry, but also the x of your vertex. You plug that number into your original equation to find your y and plot your vertex. Once you plot your vertex, you plot your c value on the y-axis, and that's going to give you half of your parabola. So then you just do the mirror image twin on the other side. All right, so let's try another one of these, or 2 more. That's so much fun. They really are. Okay, so I need to first of all identify my ABCs. Garrett, what's my A?
Square.
Yeah, what's invisibly in front of that x squared?
1.
Perfect. Okay, what is my B, Vincent? What's the coefficient of the x? What's that?
What?
The x, just the x. What's the number in front of the x? Almost, -6. You gotta take that sign with it. All right, Braden, what's C? 9. Okay, so step 1 is to use our formula. X equals -b over 2a. So let's plug in our b and our a. So we have x equals, what do I do when there's a negative?
Negative positive.
It's going to become a positive. That's 1. So that's negative 6 is actually a positive 6 over 2 times 1, which is 2. So 6 divided by 2 is 3. So x equals 3 is the vertical axis of symmetry. So at x equals 3, that's where I'm going to put a vertical line. That's going to be the middle of my symmetrical object. Okay, now I'm going to take that x equals 3 and I'm going to plug it into the original equation for x. So I have, let's see it, y equals, so I'm going to put 3 in for each of those x's. So that's step 2. 3 squared is 6 times 3. So 9 minus 18 plus 9 equals 0. So I had x is 3 and y is 0. So my vertex is at 3, 0. So I'm going to graph that 3, 0. What does my A tell me about this graph? It's a smiley, normal graph, right? So I know it's going to do this. I have one more thing to look at. The C. C hasn't done anything. It's feeling left out. So we're going to show that step 3 says that the y-intercept is at 9. So, okay, now here's a common mistake. Common mistake says that you do this. That's not right. Always start from your vertex. So the vertex, remember, the reason we checked out the A was that it was a smiley. So it's going to go up from the vertex. And if that's what it looks like on the left side of our graph, guess what the right side is gonna look like? The same thing. Oh, that's not bad. There. What's that? Yes. The line of symmetry is gonna give you, it's gonna help you identify the difference between your vertex and your y-intercept to know which one's which. Because your vertex is always gonna land on the axis of symmetry. So that's how you know to go back to that, to draw your parabola left side, right side. Okay, we're gonna do one more of these just again, because it's just so much fun. We have y equals 2x squared plus 4x minus 3. All right, Cooper, talk to me about the ABCs of this. And Sean, what is he? Have our notes with us. Yep. And what is our C, Josh? Josh, sit up, please. What is our C? It is the normal number without a variable behind it. -3. Okay. Step 1 says what, Evan? What do we do first? Step 1, Anna. X equals what? What do we use? Remember our little short formula we have to plug in? Yeah, these notes too. Yep, so there's got to be a negative b. So our formula is negative b over 2a. So we take our b, make it negative, and divide it by 2 times our a. We have -4 divided by 4, which gives us -1. So x equals -1. That is our axis of symmetry. So hey, this time our graph is going to be on the left side. We've got more to do. So I need to go ahead and plug that x in to what? What do I plug it into, Addison? The original formula in place of the x. So we got y equals 2, put -1 in for x in both spots. And now we can do some math. Hunter, what do I get when I take -1 squared and then multiply by 2? 2. Sophia, what do I get when I take 4 times -1? And -3. So Grady, what does that give us total? Yep. Okay, so y equals -5, x equals -1. So our vertex is -1, -5. So that is where we're going to graph our vertex at -1, -5, way down here. Okay, so let's just go back and get a good idea of what's happening with this graph. A equals 2. What does that tell us? pi, what does that tell us about our graph? If a equals positive 2.
Right.
But it's positive. Jaden, do you know? I know you were gone yesterday. Okay, go ahead, Addison.
Smiling and it's
It's a narrow, smiley parabola. How about this? What should I do with this? Caitlin?
put another point on the y-axis at negative.
Put another point on the y-axis in a different color than white, or it's not gonna show up. Too bad. And if I connect the vertex to the y-intercept, does that give me what I needed as far as a narrow smiley? Yep, so now all I have to do is the mirror image twin on the other side. Okay, you guys, so basically what you're doing today is exactly these 3 steps every single time. I will get you your worksheet if you want the worksheet.